Hello everybody. In this video we will talk about reaction of ethers with an acid like HI or HBr. This reactions won't happen efficiently with HCl, so we will focus our attentions with HI and HBr. So just like we have seen before, so what's the name of this ether would be? So this ether would be ethyl methyl ether, right? So that's the common name for this one, ethyl methyl ether. All right, so let's focus our attentions with our reactions. So what would happen if we have HI reacting with our ether? And we know that every time you have oxygen and an acidic proton such as H here, so that H would be abstracted by our oxygens, the lone pair on oxygens. So immediately the I will go away, run away with both of these electrons. So our product would be CH3, OCH2, CH3, and you got your acidic proton here. Now oxygen has 3 bonds, so this means it has give away the electrons, give away 1 electron. So you're going to have a formal charge of positive. So the shortcuts to remember, if you have 2 bonds on oxygen, oxygen is neutral. If you have 3 bonds on oxygen, oxygen would be positive. And if you have 1 bond, then oxygen would be negative. Okay, so what happens to the I minus? Well, I minus is chilling there. So now, every time you create a positive charge on oxygen in your mechanism, your goal should be to neutralize this oxygen. So how would you do it? Well, there are a couple of ways you can do it. You can get rid of your proton and bring back those 2 electrons, the one that you just gave it to proton. So bring it back, and then you will be neutral. But if you do so, that's basically going backward, right? So that's why this first step of the reactions is gonna be in equilibrium. Okay, so we want to move forward. So let's break something else. Now I could have break this side, I could have break this side, but I will choose to break this side because why? Because here is why. So I minus will do an SN2 attack here. So there will be an SN2 attack. And remember, if there is an SN2 attack and if there is a here, so this SN2 attack is going to be a better choice than SN2 attack here, because this is, although this is a primary carbocation, this portion is a little bit more crowded than this one. So this methyl here is the least crowded, so it's going to have preferred SN2 attack right there, and your bond will migrate towards oxygen. So there's 2 electron that's present right here is going to go towards the oxygen to neutralize it. So the 2 things that you'll be making is basically going to be your CH3I, and other side you get your HO, CH2, CH3. Okay, so that's your alcohol. Okay, so that's what we just made. But the reaction won't stop here because we have our HI is in excess. So let's try to imagine this. You are trying to cook zucchinis and potato soup. Okay, this seems delicious. So if you're trying to make zucchini and potato soup and you add salt in your crock pot, and can you make only the zucchini absorb salt and potato does not react with salt? No, we cannot, because salt is in excess. So as long as anything is in your crock pot, everything's gonna absorb salt. So both zucchini gonna absorb salt and potatoes gonna absorb salt. So if you have a crock pot, so if you have something else, maybe something else might be what's the sweet potatoes, then that sweet potatoes is also going to absorb salt because everything is cooking together. So the same thing will happen here. So you have your CH3I. This is what you just made. So this is your product 1. But if you look at here, you made an alcohol, ethanol. Now our ethanol would react. We know that ethanol also react with HI. So as soon as you make your first ethanol, this gonna go the second step of the reactions where it would react with the next set of HI. So the similar reactions, oxygen is absorbing acidic proton. So we got our CH3, CH2, and O, and this time we're gonna add another set of H. So oxygen has 3 bonds right now. So oxygen has 3 bonds right now, so it should have a positive charge. Okay, and obviously, how can we neutralize this positive charge? We can neutralize the positive charge by giving away our proton. So we can give away the proton, one of these, and we will go back where we started. So that's why this step is also in equilibrium. Okay, we want to move forward with our, okay, now it's back. We're going to move forward with our stuff. So we had our I minus, and that I minus would react with this, and oxygen would get neutralized with those 2 electrons right from here, and I minus will attack this carbon atom. So again, this is another SN2 attack right there. Okay, so now we did end up making our water. Okay, I'm not drawing this proper geometric structure because I want to show you exactly what things are breaking and how things are getting added up. Okay, okay, so that's pretty much our reactions. Okay, so let's try to rationalize this. How can we do this reactions? So let's say I'm gonna rewrite this CH3O, CH2, CH3, and you are given find the product HI in excess. So this is how you're gonna do. So you are gonna break here. So you're gonna add HI. Okay, so you're gonna add, okay, I'm gonna add different color. So you're gonna add HI, one on this side, one on this side. Okay, so the product would be, I am showing exactly how I draw there, CH3I plus H O water plus CH2 CH3 and I. So this is how the quick way to draw the products. Okay, I will stop the video here and then we'll talk more complicated example in the next videos.